Okay, so on your more kinematics sheet, we were doing number 11 and number 12. Number 11 says Ben Russian is waiting at a stoplight. So if he's waiting, that means his VI is 0. When finally it turns green, Ben accelerates at a rate of 6 meters per second squared. Okay, so A is 6 meters per second squared. The instant the light turns green, I'm a hurrying passes Ben, traveling at a constant velocity. Okay, so that's VAV. And then Ben catches up to IMA in 8 seconds. So for Ben, we have VI is 0, A is 6 meters per second squared, and delta T is 8 seconds. For IMA, we know she's traveling with an average velocity. But now what about that 8 seconds? So if here's Ben stopped at the stoplight, here's IMA going by, and then Ben begins to accelerate and catches up. So this is the delta D of Ben, and this is the delta D of IMA. And if they start at the same spot and they end at the same spot, then the delta D of Ben should be equal to the delta D of IMA. So even though we don't know what the delta D of Ben is, whatever it is, it will become the delta D of IMA as well. Okay? And then the 8 seconds. Ben takes 8 seconds to catch up to IMA, which means IMA has 8 seconds to move. So the time for both of them is 8 seconds. Okay? And the question wants to know, what is IMA's velocity? So we can't start with IMA because we have two unknowns. We don't know her displacement or her velocity. But for Ben, we only have one unknown, so we can find how far he's gone. So delta D of Ben is going to be equal to, you have VIA and delta T, so it's going to be VI delta T plus 1/2 A delta T squared. The VI is 0, so this term disappears. So it's 1/2 6 meters per second squared times 8 seconds squared. Half of 6 is 3, 8 squared is 64. So delta D of Ben is 3 times 64, which should be 192 meters. Okay, if that's the delta D of Ben, it's also the delta D of IMA. So now we have delta D and delta T. We can find our VAV. We know VAV is just equal to delta D over delta T. So 192 meters over 8 seconds. The VAV for IMA is 24 meters per second. Okay, so that's number 11. Done. Number 12. Number 12 says a jogger with a constant velocity of 4 meters per second. So a jogger has a VAV, constant velocity, of 4 meters per second. Runs by a stationary dog. So the dog, VI, is 0. Who immediately begins to chase her. The dog accelerates at a rate of 1.5 meters per second squared. So the dog's acceleration, 1.5 meters per second squared. The jogger wearing an iPod doesn't hear the dog, so doesn't speed up. How long before the dog catches the jogger? So we don't know for the jogger the time or the delta D. We don't know for the dog the time or the delta D. But what we do know is that they're going to be the same for the two of them, right? So if this is the jogger here and they run by the dog, right? So they run by the dog, but the dog accelerates and catches up. The delta D's are the same. So delta D of the jogger is going to equal delta D of the dog. The times will also be the same. However long it takes the dog to catch the jogger, that's how long the jogger has to run. So the trick here is you really have two unknowns, and to have two unknowns you need two equations. So the equation for the jogger, you can get it for delta D using your VAV equals delta D over delta T equation. Rearrange delta D of the jogger will be equal to VAV delta T. And for the dog, you can get a delta D equation because you have VI and A. So you can do delta D is equal to VI delta T plus 1/2 A delta T squared. This is for the dog. Well, we said over here that they're equal to each other. So you can, oops, and this is 0. So, sorry, delta D of the dog is really 1/2 A delta T squared. So you can take where the delta D of the jogger is, and you can write down V av delta T. And where the delta D of the dog is, you can fill in 1/2 A delta T squared. So it's just like having a system of two equations in math, like an X and Y, and needing to sub to get rid of one. So now that you're here, our only unknown is the time. We can divide both sides by delta T here. So the delta T cancels here and gives me V av. And here the squared cancels, and I'm left with 1/2 A delta T. So now I want to solve for delta T, so multiply both sides by 2 to get rid of the 1/2 and divide by A. And now fill in your numbers. Your V av was 4 meters per second, and your A was 1.5 meters per second squared. 2 times 4 is 8. 8 divided by 1.5 is 5.33 seconds, and the 3 is repeating. If you wanted to know if you did it right, just like in math, you could take it over here. The question doesn't ask, this one doesn't, but lots of them will. How far did they each travel? So you could fill it in to your 2 delta D equations. So here it would be 4 meters per second times 5 1/3 seconds. And you're going to get 21 1/3, I believe. Right? 8, 3, 16. Sorry, I'm trying to do it in my head. Times 4. Yeah, 21 1/3. Was double checking there. Meters. Okay, that's for the jogger, and then you would double check the dog. Delta D of the dog would be 1/2 1.5 meters per second squared times the 5.3 repeating seconds squared. And lo and behold, if you don't round your repeating at all, you get 21.3 repeating again. So it tells you that you got your time right because you did the delta D's and they are the same like they're supposed to. Okay, so that's 11 and 12 on the more kinematics sheet. I'll do a different video with number 1 on the harder problems.